Okay, so now that we've gotten those requirements out of the way and checked our assumptions, let's do the research. And by the way, I did have the data on my calculator, right? So let's go back to stat, this time stat calc. Just hit enter. We have the one variable, that is the mean of the difference. We have list 3. And you'll notice I've set this up. I've already set our sample size. And we're looking for these two things, the sample mean and the sample standard deviation. And I don't know why they can't program the calculator to calculate this one for us, but we also need the sampling standard deviation. So there it is, 7.364. 7.364. And then S was 6.918. There's a typo in the book, by the way, where the 1 becomes a 2. I don't know who was in charge of editing chapter 11, but they should be fired. If you didn't hear the note already that the up arrow is supposed to be a not equal sign. A few people turned in assignments with up arrows on them. And just divide that number by square root of that number, and you get something like 2.089. Okay, I'm going to split this, and we're going to do both kinds of inference procedures that we've learned. The first one will be the confidence interval, and what is the other one? The test of significance. And the book suggests 90% confidence here, so we'll do that. What is a confidence interval? We take our point estimate, that is the research result, which I'm just going to round there to 7.4. Don't know why I'm crooked, sorry. And say, okay, well the point estimate is 7.4, but how good is our research? Are we talking about plus or minus 1%? Or plus or minus 20%, because that's going to make a difference, isn't it? So what's the probability give me a range that has a very high probability of capturing the true mean, because it might not be exactly 7.4, right? Nobody's claiming it's exactly 7.4. So we do something like this. We take our sample mean and we give it a plus or minus. That's this critical value that's going to cut off these tails here. And we've set them at 5% each, right? That would give us 90% in the middle. So through our study of bell curves, whether they're z distributions or t distributions, we know about critical values. And now what do? We multiply that times our standard deviation, sampling standard deviation. So we can plug these numbers in. I'll pause the video to do that. I plugged in the numbers and realized, well, we need to look up the critical value. What is the critical value at 10 degrees of freedom for a 10% confidence? I'm sorry, 90. That's 100 minus 10. A 90% confidence level. Well, we're not going to use the 10. We've got 5% tails. That's why this upper tail probability is important. 5% is referring to the right tail. And by the way, down at the bottom of this column, it does tell you that that's the 90% confidence level column. So 1.812 is our magic number. So I brought down our mean, I brought down our sampling standard deviation, and 1.812. We'll do the multiplication, and then we'll do the addition and subtraction. Just want to remind you that this number in blue here, the critical value times, the number right here in red is our standard error. I was calling it sampling standard deviation, which is what you can think of it as. We're dividing it by square root of n, but because we don't actually have any population information, or I don't know, just to be technical, they call this the standard error. but it's still the divide by square root again trick, so no big deal. And now, what is this interval? This interval is, if you subtract, you get 3.5 on the low end. And if you add, you get 11.149 on the high end. Remember, in English, we say that this interval has a 90% chance of capturing the true population mean. In this case, the difference between not having your caffeine depression and having your caffeine depression. So one result here is that both the low end here is above 0. So we have a 90% chance of having captured the true mean, which we believe is above 0. So definitely a positive value, which means bad things for caffeine addicts. Let's take a look at the test of significance method. We're also dealing, of course, with a bell curve, in this case a t-distribution. But we start with some hypotheses. The hypotheses being the null and the alternative. And we are hypothesizing about this mean difference. And this is always the boring one, right? So in this case we say, researchers, you're wrong. You take away the caffeine addict's caffeine, and there's just no difference between placebo and the caffeine pill. And then here is where, if we had no inclination, we had no claim, we would just go ahead and say it's different. Our claim would be it's, the two are not the same. But we do actually have an inclination here that the mean difference is going to be a positive number. That is, we're going to be more depressed without our caffeine. And that makes this a right-tailed test. I'm going to choose the same size tail, just kind of for convenience here. 0.05, so we know that critical value already. That critical value is 1.812. And what do I put in the middle here? I don't put the sample mean. I put our hypothetical mean here. That is, if the null hypothesis is true, we have this picture. And then our research is going to land here. As a matter of fact, let's calculate. What is our test statistic here? We know our critical value already, but what is our test t? Our test t is going to be our research results. You'll see we're using all the same numbers that we did over on the left, minus our expected result, divided by 2089, the standard error. And we get a test statistic that's obviously further outside. Now, if we were doing something that I mentioned in the notes last time, which was a fixed significance test, we'd be done. We'd just go ahead and say, look, we're trying to beat 5%. Compare your critical values, your two t-scores, critical value with your test statistic. Boom. If I had to make a decision, and this is at the end of chapter 10 when they talk about using inference as decisions, it's like, do I keep letting these people have their caffeine or not? And you need to make a decision. And it's just like, okay, if it's on this right side of the line, we do one thing. If it's on the left side of the line, we do something different. And that has another name. It's the fixed significance method of doing significance tests. And we don't really necessarily need a p-value. We're just like, yep, it beats the critical value. So alpha is going to be, the p-value, if we knew it, would be smaller than our alpha, but we'd be done. Okay, but the p-value method is preferred, so we are going to find out what is this tiny area. The t-tails are fatter than the z-tails, but they're not that fat. And again, two methods here. Method from last assignment was just to look it up on the table. So here I have the table out again, and I'm underlining the 10 degrees of freedom. And if I just keep going out here, the p-value is getting lower and lower and lower. That is the probability in the right tail, which is what I have. And I'm just looking for that 3,525. And go, 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 and then I bump into that. So it's before I get to this p-value, but it's between those two numbers. So up here, I can say p is between that 1/4% and 0.5%. Right, that's not 5%. Be careful with your decimal places. Now, there actually is the table C and more, the actual formula for the t-statistic is in this machine here. So we can turn this on. We can go back to stat and this time do stat tests. And in chapter 10, those kind of problems, with one sample, no sigma, we do have knowledge of sigma, that is, we would use Z. Here, in this case, we're doing a significance test using the t-statistic. They say t-test for short. Notice the other examples. Next assignment we'll try looking at 3 and 4, where we have 2 samples. Next week we'll be looking at what happens when you have proportion. And look, no t-tests for proportion. And there's a reason for that. And then 7 and 8 are confidence intervals. Okay, let's take a look at, do we do data or statistics? Well, often in problems they give you the statistics, but in this case we've actually put our 11 data points in on list 3. Our hypothetical mean is 0, so this is all put in already. We want to be real careful down here because you'll get the wrong answer if you choose this incorrectly. Is it not equal, two-tailed? Is it less than, left-tailed? Or is it greater than? And sometimes students mix these up, so be real careful. This mu sub 0 is our 0, so this says less than 0. This one says greater than 0, and our alternative hypothesis is greater than 0. So you want to select that third one, and then calculate. Drum roll, please. The p-value is indeed above 0.0025, just barely though, and it was closer to that last critical value, right? So the actual p-value, I guess we can put it down here, 2.7. Obviously, at any significance level, 10%, 5%, 1%, we would reject the null hypothesis. How do we put that into English? Well, this says that there is significant evidence that the amount of depression is above 0, having taken those caffeine pills away from these poor 11 people. That this 7 is not just a statistical blip of randomness, but it is a real difference.